dear students, this is Dr. Aisha Nazuk here. Welcome back to my channel Rao Hub. Those of you who have been regularly watching my channel, they are well aware of the fact that I have been maintaining different type of playlists on my channel, ranging from simple statistics to applied econometrics and basic econometrics. Plus there are some interesting playlists about my interest in acting and role playing. So there are, the regular viewers know this fact, whereas if those of you who have landed first time on the channel, you are more than welcome to explore different playlists available here. Okay, without further ado, let's focus on today's topic, which is about the normal distribution. By the way, this is my second lecture on normal distribution in the playlist of probability theory. So if you haven't watched my earlier video on normal distribution, you may watch that to have a better understanding of today's lecture. We have been focusing on Douglas Lind book for the probability theory course. So these notes, the currently notes that I am discussing about normal distribution, they are from the chapter 7 of Douglas Lind book. The complete author names and the book title you can see on your screen, and you can easily download this book from the Genesis library. You can type in Google how to download book from the Genesis library followed by Rao Hub, or I can also post the link in the comment section and you can easily download the book from the Genesis library. By the way, Genesis library is a free public repository where you can download different type of books ranging from academics to even novels as well. Okay, so as I said, today's lecture will be focusing upon a practice question about normal distribution. So the first practice question that I'm going to discuss is a word problem to help you practically develop an understanding of the normal distribution. So the first word problem is, let's say we have data of some graduate schools of business students who want to take admission to GMAT examination. So let's say we know that the scores on the GMAT are roughly normally distributed with a mean of 527 and standard deviation of 112. So we want to find the probability that an individual will score above 500 on the GMAT. So this is the data. We are going to make a graph and then we will solve it. So let's go to the graph. Okay. So the data given was, refer back, you can see that the average is 527 whereas the standard deviation is 112. So we know that the notation for average is mu, the Greek symbol. So mu is 527 and standard deviation, that is sigma, is equal to 112 or 112. And we need to find the probability that someone scores more than 500 marks in GMAT exam. And it is given that the scores follows normal distribution. So I'm going to use the normal distribution table to compute this probability. Here you can see an excerpt or a screenshot of selected area of the normal distribution table. You can easily download the normal distribution table from the internet, and if you want to me to post a link to the table, once again post a comment in the comment section and I will post the link as well. For my students who are enrolled in NAST and they have connected with me through the LMS portal, I have also uploaded the normal distribution table on the LMS portal. Okay, so we want to compute the probability that the random variable takes a value greater than 500. So we know that we always convert the required variable into its standardized form, which is z-score. And formula for z-score is observed value minus the mean divided by standard deviation. So here we are computing the probability for 500. So observed value is 500 minus mean, which is 527, divided by standard deviation, which is given in the question as 112. So once you compute, this number comes out to be minus 0.24 roughly. Okay, so let's show this number on the graph. So we know that normal distribution is a bell-shaped distribution and it has a center always at 0. So negative 0.24 will be somewhere towards the left of 0. So what we are going to do, we are going to read the table for plus 0.24. Remember that there are different versions of normal distribution tables if you use from the internet. from the version that I'm using, it is only being generated for positive values of z, but we can easily use it to find the probabilities for negative values of z as well. The reason I'm mentioning about different forms of the normal distribution table is just because if you use different books and if you use internet resources, don't get confused. We can have different forms, but the table that I'm discussing is the one in which we have only z values are positive. As I said that I'm focusing on the Douglas Lind book, so this table is also downloaded from the Douglas Lind book. By the way, it's available at the end of the book. So okay, so I'm going to read the table for plus 0.24. As I said, it's not available for negative numbers, so I'm going to read it for plus 0.24. Okay, so but I don't need the answer for plus 0.24, although the table gives me plus 0.24, but I need the answer for minus 0.24. So what I'm going to do, let me take you to another screenshot to help you understand how I'm going to use the table. You see that we know that the normal distribution is a symmetric distribution. So if, for example, the probability or area behind minus 0.24 is equal to the area towards the right of plus 0.24. So I have shaded these two areas as yellows. So these two areas are equal. So this is what you need to understand first. So if I read the table for plus 0.24, let me draw another line here at 0. So if this line is representing, let's say, 0, let me type it for you here. Okay, so this is the 0. If I read the table for plus 0.24, the answer that whatever the table gives me will be the area here. Here. So this area, if I read the table for plus 0.24, the table will give me the answer for this area where I have drawn these, irregular pattern lines. Okay, let me go back to the slide and let's discuss further. So if I read the table for plus 0.24, it's going to give me an area for this portion, right? But this area is not linked with the other one. So what I can do, if I subtract this area from 0.5, I'll get this area minus 0.24. I repeat, if I read the table for plus 0.24, I'll get this area. Then I'll subtract it from 0.5 because half of the bell shape is 0.5, right? So then I'm going to subtract it from 0.5, and that answer will be, let me choose the correct color. Yeah, so the answer will be this area, which is equal to this area, right? Going back to the slide. So you see what I have written. Read the table for plus 0.24 and subtract it from 0.5 to get area to the left of minus 0.24. So the table gives me 0.0948. If I subtract it from 0.5, the required, the answer is 0.4052. Right? Okay, but I don't need this area. In the question, I need the area that x is greater than 500. In other words, z is greater than minus 0.24. So I don't need this area. So what I can do, if I subtract 0.4052 from 0.5, I'll get this yellow part, right? Area between minus 0.24 to 0, which comes out to be 0.095. And the other area is simply half of the bell shape, so it is 0.5. So now I have found the two portions. I can now simply add these. So plus 0.095 plus 0.5, you can say that it will give me the required area. So see, I have written here 0.095 plus 0.5, which gives me 0.595. So the probability that someone scores greater than 500 marks in GMAT exam, in this scenario, it is roughly equal to 60%, as if you can round it off, or you can report it as it is 59.5% is the likelihood that someone is going to score greater than 500 marks in the GMAT exam. So this was our first word problem. I hope it was clear, and I've repeatedly announcing on a friendly note that if you want to discuss any queries, please post your comments in the comment section. I will try my best to, get connected with all my viewers on the cyberspace as well. Okay, the second part of the same word problem is, pardon, how high must an individual score on the GMAT in order to score in the highest 5%? In other words, if you want to be the top 5% scorer in the GMAT exam, how high marks should you get? So you can see I have also shown the same information here in the graph. So according to the graph, we don't know what is the score. That's why this is a question mark here. We don't know how high we should score to be in the top 5%. Okay, so this area is 5% or 0.05. Well, we know that the table is available from the center till a particular value. So if I subtract it from 0.05, I get 0.45. So now what I'm going to do, I'm going to read the table for 0.45. So now what's so special about this part of the question is, here I'm going to, I know the probability, right? I know the probability, and I'm going to compute the required x value, which is shown here as a question mark. So how am I going to do it? Let's take you to the screenshot of the table again. If you read inside the table, because now I'm making use of the inverse use of the table. Refer back. I'm looking for 0.45 inside the table, but I don't have exact 0.45 available. The closest possible value is 0.4495, against which z-score is 1.64, right? You can see 1.64. Okay, so since the required x value is towards the right side of the mean, or towards the right side of the bell shape, so I'm going to use the z value as it is in its positive form. So this is the z value. Now how come it's going to help me to compute the x value? We know that the z-score is equal to x minus mu over sigma, where x is the observed value. We don't know what's the observed value here, because you see there's a question mark. We don't know how many marks should we get, so x is unknown, but we know mean, we know the standard deviation, we have computed this required z-score. So now you simply switch on the value of z-score. You already have mu and sigma, and just simply solve it for x, and you simply get that you need to score roughly 710 marks to ensure that you are in the top 5% of the students, right? So this was about inverse use of the z table. Next we have another word problem. Okay, let's read the statement for you before I solve. The average number of acres burned by forest and range fires in large New Mexico County is 4,300 acres per year, with a standard deviation of 750 acres. The distribution of the number of acres burned is normal. What is the probability that between 2,500 and 4,200 acres will be burned in any given year? So now you can see we are given the average standard deviation. So mu is 4,300, standard deviation is 750. Now the area which we want to compute is between 2,500 and 4,200. So what I'm going to do, I'm going to compute the z values for both of these observations. So first I compute z value for 2,500. As I said, observed value minus the mean divided by standard deviation. So z for 2,500 comes out to be minus 2.4, whereas z for 4,200 comes out to be minus 0.13 approximately. So we need to find the area between minus 0.24 to minus 0.13. Okay, so I've shown here in the graph, you can see I have plotted the actual values along with their corresponding z values. So we computed z value for 2,500 equal to minus 2.4, whereas the z value for 4,200 is minus 0.13, and we know that the z value in the center, that is against the mean, is always equal to 0. Okay, so the required area I have shaded here as yellow. Since both the z values are negative, as I said, the table is not available for the negative value. So for example, if I want to compute the value for minus 2.40, what I'm going to do, I'm going to read the table for 2.40 and subtract it from 0.5, which will give me area towards the left of minus 2.40, right? So you can see against 2.40 the required area is 0.4918. If I subtract it from 0.5, it gives me 0.0082, which is area towards the left of minus 2.40. Similarly, if I read the table for 0.13, it gives me 0.0517. In the similar fashion, I am going to subtract it from 0.5 to get the area towards the left of this z-score. So now I know, you see I've drawn this big line, orange color, and green curve. So this orange line represent area towards the left of minus 0.13. This green curve represent the area towards the left of minus 2.4. But I don't need these separate areas. I require this yellow part. So how can I compute? The bigger part minus the smaller part will give me this yellow area. So I'm simply going to, you see, subtract 0.4483 and 0.0082 to get the required probability, right? So I hope by doing these questions the topic of normal distribution is relatively more clearer now. We have another part of this question. Here, by the way, we are focusing on another concept, which is percentile. So if you don't have any, I'm sure that if you are enrolled in a course of probability theory, then you have some background of statistics. Just in case if you are exploring this course on your own or the topic on your own and you have no idea what is percentile, then you should go back to my playlist Introduction to Statistics, where I have a complete lecture on quintiles, percentiles, and deciles. Once again, more than welcome. If you want me to post the link to that lecture, please post your comment in the comment section. I'll post the link there. Okay, anyhow, so the question says, what number of burnt acres corresponds to the 38th percentile? Okay, so 38th percentile means any number which covers 0.38 area before it. Okay, what does that mean? 38th percentile means a number which covers 0.38 area before it. For example, if we were computing, let's say 60th percentile, then that area towards the left would have been 0.6. So here we have 38th percentile, so the area towards the left of the required number is 0.38. Okay, so this is 0.38. So that means, but remember that the table gives me area from 0 till a number, but here it's giving me area towards the left, so I'm simply going to subtract it from 0.5 to get this area, which is 0.12. You can see area from z is equal to 0 to z is equal to minus 0.31 is equal to 0.5 minus 0.38, which is equal to 0.12, right? This area is the area I haven't shaded with the line. So this black white area here, I'm moving the cursor right now, it's 0.12. So what we are going to do, we locate 0.12 in the table. So exact 0.12 is not available. The closest possible number is this 0.1217, against which z-score is 0.31. But we are looking for z in the left tail, so I'm going to attach a negative sign with this z. So required z is minus 0.31. Now we are going to simply use the same z-score formula, which is x minus mean over standard deviation. We know the z value, we know the mean, we also know the standard deviation, so we can simply solve it for x. We get that the required x is equal to 4067 roughly. Okay, so this was another practice activity where we made use of the inverse use of the table. Now we have the last practice question for this lecture. Let's say that the distribution of systolic blood pressure in a population of hypertensive women is modeled well by a normal probability distribution with average blood pressure of 100 mm and standard deviation of 14 mm. So let x be the random variable representing this distribution. We need to find two symmetric values a and b such that the area between them is equal to 0.99. So I have shown the same word problem in the form of a graph. So here is the value a and b. So area between them is 99% as it is given. The probability is 0.99. So if I divide 0.99 by 2, I get 0.495. So I'm going to read the table for 0.495, and the required z comes out to be 2.54. So you see, if the positive value is 2.54, so the negative one will be minus 2.54. So I'm going to simply put z once as 0.254 and once as minus 2.54. Remaining z-score formula is the same, observed value minus mean over standard deviation. So you can compute the two x values simply. So you can see that the lower range, or the a value, is 64, whereas the b value is 135 roughly. So this was another word problem where we made use of the inverse use of the z table. For more practice question, if you are connected with me on LMS, which is only possible if you are enrolled in NAST University, as I said, that I am a regular faculty member at NAST University. So if you are connected with me, you can have resources there, but no need to worry. If you are a general viewer, I'll shortly share my email address as well, which I always share towards the end of each lecture. So you can always write me an email, you can post in the comment section. I want to develop a regular, learning community where we are connected with each other. So it's not only about watching one video and then you are gone. I would like to share my intellectual capital and whatever intelligence I have in my humble efforts. So you can always drop me an email or post a comment. So this label, yeah, it's for only for my NAS student, where I have uploaded some practice activities on the learning management system portal. Anyhow, you can use solved example of Douglas Lind book as well for additional practice activities. The good part is that I haven't used the solved example. All the questions that all the practice questions that I discussed today, they are not from the Douglas Lind book. They are additional. So these are an additional sort of resources. Now you can go and acquaint yourself further with the topic. You can go to the book and you can focus on the solved examples to see, without looking at the solution first, that you are able to come up to the required answer or not. Okay, so in the end, I would like to thank you for watching, for your patience. I know that learning people generally have, I'm not judging anyone, but generally we have lesser attention to span nowadays. So if you have watched the entire video, thanks a lot. I like to get connected with my community, so towards the end of each lecture I share some of my activities. So here is a picture in where I participated in a cycling event. By the way, it was organized by the Girls Cycling Squad here in Islamabad to observe the Women Day 2020, and the theme was to develop an inclusive society, a cohesive society. So it was a wonderful experience participating in that cycling marathon, in which we were a group of students and a couple of faculty members as well. So it was a good experience, and I hope that by sharing, the purpose is not to tell you what I'm doing. The purpose is that that here in the cyberspace I'll try to give the maximum humanly touch. So your professor, Dr. Aisha Nazuk here, would like to share now the email address. So you can see that this is my personal email address. I can also share my official address, but the reason I always share my personal email IDs is that one can change workplace anytime. Though I don't have any such plans, but one can. So I always share my personal email IDs for people I want to stay connected in the long run. So you're welcome to watch the playlist on this channel. Thank you once again, and see you in the next video lecture.